Planets form, night sky wonders. The story of planet formation is one of dust, gas, and gravity coming together in a cosmic dance that spans millions of years. And today, we're going to unravel one of the most fascinating theories in astrophysics, the disk theory, which explains how planets like Earth, Jupiter, and even exoplanets beyond our solar system came to be. By the end of this video, you'll not only understand how planets form, but also gain insight into the origins of our own solar system. So stick around. To understand how planets form, we need to go back 4.6 billion years ago to a time when our sun was just a newborn star, surrounded by a vast swirling disk of gas and dust. This is what scientists call a protoplanetary disk, and it's the key to how planets are born. Planet formation starts with a star. Most stars, including our sun, form from massive clouds of gas and dust known as nebulae. When gravity causes a nebula to collapse, it begins to spin, forming a flattened disk around the newborn star. This is the protoplanetary disk. But why does this happen? It's all because of angular momentum. Just like an ice skater spins faster when pulling their arms in, the collapsing cloud spins faster as it shrinks, forming a disk around the star. This disk is rich with elements hydrogen, helium, and heavier elements like carbon, silicon, and iron. Over the next millions of years, these tiny particles will collide, stick together, and gradually grow into planets. So, how do tiny dust particles turn into massive planets? The process is called accretion, and it works like this. One exact dust grains stick together, forming pebbles. Two pebbles collide and create bigger clumps, called planetesimals, about 1 kilometer wide. 1. Some planetesimals become large enough to pull in more material with gravity, growing into protoplanets. 4. After millions of years, these protoplanets either merge or clear their orbits, becoming fully formed planets. The key to accretion is gravity. The bigger a planetesimal gets, the stronger its gravitational pull, allowing it to gather even more material. Some of these early planetary embryos would go on to become the planets we see today. But here's an interesting question: why? Are some planets like Earth and Mars rocky, while others like Jupiter and Saturn are giant balls of gas? The answer lies in temperature. Close to the sun, in the inner solar system, it was too hot for volatile gases like hydrogen and helium to stick around. Only heavy elements like iron and silicates could form solid planets. This is why Mercury, Venus, Earth, and Mars are rocky planets. But farther from the sun, in the outer solar system, temperatures were low enough for light gases to remain. This allowed planets like Jupiter, Saturn, Uranus, and Neptune to grow massive, collecting thick atmospheres of hydrogen and helium, creating the gas giants. Once a planet forms, it doesn't just stay a random mix of materials. Something important happens: planetary differentiation. This is where heavier materials, like iron and nickel, sink to form a planet's core, while lighter materials, like silicates, float to form the crust. This is why Earth has a dense, metallic core, a hot mantle, and a solid crust stand. This process played a huge role in shaping habitable planets. But planet formation wasn't a smooth process. In the early solar system, massive collisions were common. Scientists believe that around 4 billion years ago, a period called the Late Heavy Bombardment saw asteroids and comets smashing into young planets, shaping their surfaces and possibly delivering water. Some scientists even think that Earth's moon formed when a Mars-sized planet crashed into Earth, throwing debris into space that later became the moon. One of the most exciting discoveries in recent years is that planet formation isn't unique to our solar system. We've found thousands of exoplanets, planets orbiting other stars, some rocky, some gaseous, and some completely different from anything in our solar system. We've even found hot Jupiter's massive gas giants that orbit their stars way closer than Mercury does to our sun. These discoveries are changing our understanding of how planetary systems evolve. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more mind-blowing space documentaries.